And for what we have here, okay, so you have, again, the product would have to be greater than 0. And if we identify the zeros, so we have with x minus 3, we have x equal to 3. And from x plus 6, I have x equal to negative 6. And rank ordering the zeros from smallest to largest, or smaller to larger, I have negative 6 and 3. We have the values of x less than negative 6. And then we had those values of x between and not including negative 6 and 3. And we had those values of x greater than 3. And again, just to test out each of the subintervals, okay, we assign a test value x. So for the first subinterval, we're looking at plugging in anything that is less than negative 6, and negative 7 would fit the bill. It could be negative 1,000, negative 1,000,000, but negative 7 is sufficient. And we have anything between negative 6 and 3. 0 will be such a value, and for the last subinterval, which we had to consist of values of x greater than 3, 4 will fit the bill. And taking each of these inputs, so if I have for f of x equal to x minus 3 quantity squared times the quantity of x plus 6, if I plug in negative 7, the output is a minus 100. Plugging in 0, you have like negative 3 squared is 9, and you have times 6. 9 times 6 is 54, and with x at 4, 4 minus 3 is 1, square of 1 is 1, 4 plus 6 is 10, 1 times 10 is positive 10. And for the sign of f of x less than negative 6, okay, the result is negative, so we have that f of x is less than 0. Anything we plug in between negative 6 and 3, but not inclusive of negative 6 or 3, the output will be positive, so we have the f of x is greater than 0, and anything we plug in greater than 3. And so we have here the output is also positive, so we have the f of x is greater than 0. And so for what we have in this particular situation, okay, is that whereupon we have the square of x minus 3 times the quantity of x minus 6 to be greater than 0, we're going to have with the solution, and this will be where we have f of x to be greater than 0. So we have for the first subinterval section, we have negative 6 to 3, okay, in parentheses, and we have followed by those values of x greater than 3. And so if I relay this on over to what we have here, okay, so we have so you have between negative 6 and positive 3. And taking what we have this time, the union symbol, and we have going from 3, and we have on out to infinity, and checking, and the result is correct. Okay, for what we have in the case of number 4, okay, we're looking at solving the inequality where we have x plus 1 all over negative x minus 6 is less than 0. And so looking at what we have now, okay, so we have x plus 1 over negative x minus 6 is less than 0. And if I identify the zeros, so we have from the numerator, have x equals to negative 1. From the denominator, okay, if I make the negative x minus 6, multiply both sides by negative 1, rewriting where we have x plus 6 is equal to 0, we can easily get to that 0 value at negative 6. So rank ordering the zeros from smaller to larger, we have negative 6 and negative 1. And again, if I have x at negative 6, the denominator would be 0 in value. And again, for a rational expression to be defined, we cannot have a 0 valued denominator. So negative 6 is not in the domain, but we're going to use it in the table setup. Negative 1 is in the domain. Now, you have, so if x plus 1 is situated where we have x equal to negative 1, x plus 1 becomes 0, and you can have a 0 numerator as long as you do not have a 0 valued denominator. Okay, so we have, with the interval sections, okay, so you have going from negative infinity approaching but not including negative 6. and we have bypassing -6, nearing but not including -1, and we have bypassing -1 heading on out to an infinity. Now, testing each of the sub-interval sections. Okay, now for the inputs, okay, if I plug in any value less than -6, -7 fits the bill. Anything for x that is greater than -6 and less than -1, -2 would fit such a description. And anything greater than -1, we have 0 as a possible input value. And so plugging each of the quantities, the -7, -2, and 0 into f of x is equal to x plus 1 over -x minus 6. Now we have with -7. Now -7 plus 1 would be -6. Now for the negative of -7, that would be positive 7 minus 6 is going to be 1. And you have -6 over 1 ends up at -6. Now for -2, we have -2 plus 1 is -1. Opposite sign of -2 is going to be positive 2 minus 6 is -4. -1 over -4 comes out to a positive 1 over 4. And for 0, we've got plus 1 over -6. So we have a minus 1/6. Now, for the sign of f of x, okay, first interval section, okay, for values of x less than -6, the output is going to be negative. So we have the f of x will be less than 0. Anything we have in the middle for x, okay, we have a positive output. So we have the f of x is greater than 0. And we have in the last case, all right, so we have any value of x greater than a -1, the output is negative. So we have the f of x is less than 0. Okay, now, in looking at what we have for the inequality, now we have x plus 1 over -x minus 6 is less than 0. And where we have, again, so we have f of x refers to the ratio, where we have to be less than 0. So we have with the results here, so you have values of x that will be less than -6. And then we have values of x that will be greater than -1. Okay, and before I key that into Aleks, let me mention something here regarding what's in the domain and what is not. Okay, now, if you have x plus 1 over -x minus 6 to be not less than, but less than or equal to 0, now you'll be looking at the same limits. Okay, but now the equal sign considers a possibility that you may have brackets in the mix. And brackets will go around finite zeros that will be in the domain of the function. And okay, so we have, in this particular case, all right, so we have -6 is not in the domain, not in the domain. And to just indicate in red, not in the domain. -6 is not in the domain. And if a 0 is not in the domain, okay, that is going to be in parentheses. And we have in the case of -1. Now, -1 is in the domain. And for what we have here, since -1 is in the domain, the enclosure around -1 would be a bracket. All right. But going back to what we have with our problem in number 6. Okay, so we have looking at combining what we have here. So we have for the first interval section, okay, so we have parentheses throughout, and we have with the input, we have going from -infinity, approaching, but not including -6. And we have the other part of the solution, we have going past -1, and we have approaching positive infinity, and checking the result. And the output is correct. For what we have in the case of number 5, okay, we're looking at a comparison inequality between two ratios. And now, so here we have -2 over 7 minus x is greater than or equal to 1 over x plus 1. And if I rewrite this expression as a comparison to 0 inequality, so I can move the 1 over x plus 1 over by subtracting. And what I can do is I can just rewrite this comparison statement. If you notice, I have -2 over 7 minus x. Now you can leave this ratio as it is, but I thought it would look a little bit more user-friendly if I just multiply by 1 in the form of -1 over itself. We had translating to where we have the x term in the denominator is positive, and where the constant will be the negative. And we have, so multiplying by -1 over -1, we have 2 over x minus 7. And we have in the rewrite, so we have 2 over x minus 7. And we have -1 over x plus 1 is greater than or equal to 0. And if I consolidate what I have here as a combined rational expression, so joining together, we have 2 over x minus 7 minus 1 over x plus 1. Now the least common denominator, we had the quantity of x minus 7 times that of x plus 1, and multiplying by 1 in the form of the missing factor from the least common denominator divided by itself. So we have a 2 over x minus 7. We got the x minus 7, but missing the x plus 1. For 1 over x plus 1, we're missing the x minus 7. So applying the treatment, we have, and combining the terms, okay, so you have distribution, you have 2x plus 2. Now we're going to be distributing subtraction over the second ratio numerator. So we have the quantity of x minus 7 that will be subtracted over, and combining what we have here. So we have negative x plus 7, and joining with 2x plus 2, we have x plus 9 all over the quantity of x minus 7 times that of x plus 1. And we have with the zeros from the numerator, I have x equal to -9, and you can have a 0 numerator as long as you do not have a 0 denominator. So -9 is in the domain, whereas in case of 7 and -1, those stem from denominator factors. They are zeros, but they are zeros that are not in the domain. Okay, and we have, in setting up a table, so we have as an input value for the first interval, we have -10, and then we have -2 for the second interval, 0, since we have 0 to lie between -1 and 7, and 8 can be chosen, okay, for the last interval test amount, okay, and we have plugging in each of the values into f of x equal to the ratio x plus 9 divided by the product of x minus 7 and x plus 1. So we have f of -10 is -1 over 153, and the sign of f of x is going to be negative. So we have here that f of x is less than 0. And then we have next, okay, we have with -2, the result we had to be a positive 7/9. So here we have that f of x is going to be greater than 0. And then we have next, okay, we have for the third subinterval, output is going to be negative. So we have the f of x is less than 0. And for the fourth subinterval, okay, we're going to have positive output, whereupon we're going to have the f of x is greater than 0. Okay. All right, so looking at what we have now. Okay, so we have, again, start out with our inequality and just put it in condensed form. And where we have that essentially f of x will be greater than or equal to 0. So we have, looking at starting out with where f of x is greater than 0, we have the limits. So we have -9 and -1. And where we have f of x be greater than 0, we have involving 7 and an infinity. And now for the enclosures, I'll use a little bit of color coding. Okay, so -9 is in the domain, and since that the equal sign, okay, that includes the possibility of brackets along with parentheses. So -9 is in the domain. Any 0 that is in the domain, we can bracket, and anything that is not in the domain, okay, we leave in the parentheses. Okay, so we have -1 is going to be in parentheses as well as 7, and again, infinity is boundless, so that is going to be in the parentheses as well. Okay, so we have testing out what we have here, and had a little bit of a keystroke error earlier. Okay, so I had it incorrect, and now, so we have just for this inequality. So we have again we have going. Okay, so we have close at -9. We have to -1. And then we have the other portion was going past 7 on out to infinity. And just checking the result. And the result is correct.